I was experimenting how to glue this serial interface onto some board. I use some distance of these plastic strips, so it's the upper part of the pins do not get through the surface of the board. So then I put some glue on it and I pushed the interface on it, and now we will see if it works, if it fits fine. So then this is the final result. I think it's a very good idea. As you can see, I mounted an extra rail of Wago clamps. It's connected to the 3.3 volts from the microcontroller. And also I also want to check if my rotary encoder, which I attach to the system, well, it's not that nice, but I like to make it modular. Because here's an example of how I used another rotary encoder. It's integrated into the system, but you can replace it simply. So I made me this modular one with some distance holders using straw. Looks a little bit strange. I put the wires through them to the microcontroller. And I had to rewrite the program because on this one, the A and the B line of the rotary encoder, one of the lines is connected to the I2C, I2 data bus. So I had to put it to another pin of the microcontroller, line A, and rewrite the program. To test if the program is working, I need a serial port to report the results, and if the results are okay, then I will change the software that when turning the knob, it will change the frequency, the receiving frequency of the FM receiver. So this is my old system. This is another project where I used the serial port with the 6-pin interface. This is the new system. I only need to remove the jumper and use these 3 wire grounds, RX and TX. So I also updated my wire color document. These are the Dutch words. These are the English words. For the I2C serial clock serial data, I use purple and brown. For the RS485 A line, B line, I use A for amber orange, B blue. And I also use these colors for the A, let me get away the cursor, from the A line of the rotary encoder and the B line of the rotary encoder. And we have the audio left and right, gray and white. And for the serial port communication, I use the yellow for the TX and green for the RX. As I do not have enough wires, male, female, with the color black, I just take me a white one and then I color it black. So now I connected my serial port, transmitter, receiver. The green wire is the RX of the receiver, so it's the TX of the microcontroller. It's pin 2, because here is my main program, main.c. It doesn't get very sharp, but it is pin 2. It's the UARTX. That is this green wire going to my serial port. And now I will have to change my program that the rotary encoder output is going to the UART. So therefore I modified my I2C program. These initialize all modules, these starts the modules, these run the modules. So I've added UAT1 in it, UAT1 start, UAT1 run. Just for these persons that are interested in programming, I use two interrupt handlers, the A and the B, corresponding to the A and the B lines of the rotary encoder. This is interrupt handler line A, this is interrupt handler line B. Both go to the function, this one, handle something, go to the definition of it, and this is then this function that handles, and it looks like all kinds of things, and finally it writes a counter value. Turning right it increases, turning left it decreases a value. It writes it to a ring buffer, and somewhere in the main application, I don't know if it can find, but anyway, somewhere in the main application it's looking if there is data in the ring buffer, and then it transfers it to the serial port. Well, this is this function in the application. Every module has a state machine, but every module also runs continuously certain functions, and I call it real time. And you see if there is a character in the ring buffer, then write it to the UAT. So finally I got the rotary encoder to work. I made a mistake. I looked at these pins, but these colors are seen from the microcontroller. So the yellow is the TX from the microcontroller, but it is the RX from the USB interface. This should be green. So I created here another connector, which is seen from the USB device. Green is the RX, is going into this device, going to the USB side. So now it finally works. My rotary encoder. If I look at the hyperterminal, you can see even if I turn it very fast, you see a consequence of characters, especially for 0 to 9. It's very fast, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's working very fine. But now we have to connect the internal microcontroller output that generates this hyperterminal code. It has to be connected to the I2C project's module that generates the frequency of the stereo audio FM receiver here. Hi viewers, I would like to integrate my rotary encoder. There's a special, I created a special program to decode it and send data to the serial port. But I integrated this program into my FM radio receiver, and I like to use a modular approach. So it's looking very big. This is my rotary encoder with the Waco clamps going to specific microcontroller pins. I also added an extra clamp for the 3.3 volt, and I also added a serial port interface with the new system without those plastics, and I can say it works. So if I put on the volume, I cannot put the volume too high because the amplifier is fed by the 3.3 volt coming from the interface. I also could power it up with the 5 volt, but I like to work with the absolute minimum, and I connected it not to the internal speaker, but I connected it to the speaker there. You can see the cable, and if I turn the knob, it changes the receive frequency by 0.1 megahertz. Each time I turn the knob, an I2C message of 5 bytes is sent to the radio receiver. But I don't hear not much. Oh, because my debugger has. Well, the radio is working. Let's see if we can find some stations. Each step is 0.1 megahertz. In hyperthermal I can see if it's turning right or left. It's very accurate. It was a little bit unstable, but then I added myself a capacitor of 100 nanofarad over the A and the B lines from the rotary encoder, and then it was very stable. And if I press the button, it goes to the local station. You can count, if I deviate 10 steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's again back on the original station. Thanks for watching.